Okay, let's solve a really weird kitchen mystery. It's a tale of two loaves of bread. You've got one that gets old, exactly like you'd expect, but the other one? Well, the other one seems to defy the laws of time itself. You know the deal, right? You go to a fancy bakery, you buy this beautiful artisan loaf, and by the next day, it's already starting to feel like a rock. But then you've got that cheap, plastic-wrapped supermarket bread, and on day 4, you can still squish it and it springs right back. It just feels completely backwards, doesn't it? I mean, usually, the cheaper the food, the faster it goes bad. But with bread, that rustic loaf with 3 simple ingredients goes hard, while the one with the cartoon mascot stays soft for days. What is going on here? So we're officially opening the file on this one. We're calling it the case of unnatural softness. We expect fruit to get old, to harden, to spoil. This bread's refusal to do that is what makes this whole thing so fascinating. Every good investigation starts by interrogating the usual suspects. And when it comes to bread that seems to stay soft forever, there are a few common explanations people throw around. So let's line them up and see which ones actually hold water. All right, suspect number 1, the one everyone points to first, preservatives. We all just assume the bread is packed with chemicals like calcium propionate to keep it fresh. And look, that's not wrong, but it's definitely not the whole story. And here's the crucial distinction you've got to understand. Preservatives? They are absolutely brilliant at stopping mold from growing. That's their job. But stopping mold is not the same thing as stopping the bread from getting hard and stale. Those are two completely different problems. Okay, so if it's not just the preservatives, what about the packaging? Suspect number 2, the plastic bag. It has to be trapping moisture, right? That makes total sense. And yeah, the bag definitely helps. It keeps the moisture from escaping, which slows things down a bit. But the main event, the real crime that makes bread feel stale, well, that's an inside job. It's an architectural change happening deep within the loaf itself. So let's just get rid of this idea that it's fake bread. It's not. It's real bread, made from real ingredients. The difference is that it has been very, very deliberately engineered to age differently than that rustic loaf from the bakery. Now it's time to pull out the microscope. The evidence we're looking for isn't just on the ingredient list. It's deep inside the bread's molecular structure. This is where we find the real culprit behind what we call staling. And here's the big twist in our investigation. Bread doesn't go stale just because it's drying out. The real enemy isn't the air. The enemy is the bread's own internal architecture, which is literally changing and locking itself up from the inside out. The official scientific term for this process is starch retrogradation. So think of it like this. When bread is fresh and warm, all its starch molecules are like a messy, jumbled pile of logs. They're soft and they can move around. But as the bread cools and ages, those logs start stacking themselves into neat, tight, and very hard crystalline piles. That reorganization is what makes the bread feel hard and stale. And this is the part that's kind of mind-blowing. It proves that staling isn't just about drying out. In fact, stale bread can have almost the exact same amount of water as fresh bread. It just feels drier because that water has been locked away inside those newly formed starch crystals. So if starch retrogradation is our culprit, how do you stop it? Well, commercial bread doesn't fight this crime alone. It brings in a whole team of accomplices, a toolkit of special ingredients designed specifically to get in the way of that crystallization process. The crucial thing here is that it's a multi-pronged attack. You've got emulsifiers that act like little wedges, getting in between the starch molecules so they can't line up so neatly. Then you've got enzymes that are like molecular scissors, snipping the starch chains to make them harder to organize. Fats and gums help manage moisture, and that plastic bag, it's just the humidifier, keeping the whole environment stable. Let's focus on those scissors for a second. Specific enzymes called amylases are added to the dough. Their only job is to snip starch molecules in very particular places. It's like giving the starch a very specific haircut, which makes it much, much harder for it to crystallize later on. It basically just slows the whole staling process way down. So you see, that cheap loaf isn't winning because of some magic trick. It's winning because it was intentionally designed and optimized, not just for taste or for price, but specifically for softness on day 3, day 5, and even beyond. So now that we've cracked the case, what does all this mean for the bread sitting in your kitchen right now? Let's decode what we're actually seeing every day. Well, this science explains a ton. It tells us why your homemade loaf goes stale so fast. It just doesn't have that anti-staling toolkit. It clarifies that softness doesn't always equal freshness. Sometimes it just means really good engineering. It shows us that a crusty baguette and a squishy sandwich loaf are built for completely different missions. And really, reading that ingredient label is like reading a strategy for texture and time. But wait, here's the final twist in our investigation. It turns out this crime of stalling, well, it's not entirely permanent. You can actually fight back. Think about it. We all do this without even realizing the science. Why does popping a slightly stale slice of bread into the toaster seem to magically bring it back to life? This is our final piece of evidence. That heat provides enough energy to literally shake up those tight starch crystals, forcing them to loosen their grip and release some of that trapped water. It temporarily reverses the retrogradation, bringing back that soft, fresh-like texture, even if it's just for a moment. So in the end, we see the mystery was never really, why is this bread still soft? The real question, the much cooler question, is this. How many tiny, deliberate, scientific decisions were made so that this one loaf of bread would still feel soft when you finally got around to making a sandwich on a Thursday? It's not magic. It's just amazing engineering.